Hi there, welcome back to the channel. If you're a regular viewer of my channel, you would definitely have heard me speak about the mini whip antenna. This thing is absolutely magical. It sits on top of the roof. I'm on the top floor of an apartment building, so this thing is unobtrusive. It is fantastic. It receives incredibly well all the way from the long wave to the end or the top of the shortwave bands. This, what you're seeing here, is the undershelf unit that provided the power to the mini whip antenna. So it's the bias T section, and it allows me to get easy access to the whole control of the antennas. I also had an FM antenna coming in the back, which was just coming out of that second socket on the right there. What this meant was that if I was listening to AM, I would have it connected to the one socket. If I wanted FM, I had to disconnect it from one, put it to the other. I thought a switching system would be a lot better. I also decided to redo those undershelf modules out of a 3D printed version because the aluminium elements were difficult to get. And in a previous video, I also showed you how I did that. I 3D modeled it. I can now 3D print that in any shape or size that I want. I also designed these faceplates where I can 3D print in multicolored filament and get the labeling on. And the whole idea is that it becomes customizable for any of the other units that I might want to redo or new ones that I want to make. And what tends to happen when you experiment and you've got a 3D printer that you can use anytime you like, any time of day or night, as long as your wife lets you. I made a lot of versions. I try to get the best version of the text. I extrude it in, I extrude it out. I'll be showing you that later. What this video is about is something else. This video is about taking that mess and putting it on here. I designed a PC board which incorporates the switching function using a miniature relay. I like these little relays. I'll show you them when I get to the description. And it also does the bias T work for the mini whip. Now, what happens is the mini whip uses a supply. It requires a supply. And the way that is achieved is you actually pump or you feed a DC voltage, in this case 12 volts, into the coax. And that goes up the coax to feed the mini whip. The same coax brings down the radio signal. It's called a bias T, and you use capacitors to isolate the RF end at the mini whip and the received RF here from the DC with some capacitors. But it's not complicated. I'll be showing you that on the schematic. And this little project is really just me trying to get this whole thing neatened up. I'm a little bit, I'm a little obsessed with that. I like these things to look good, and I really was never happy with what I had over there. So I did the boards. I ordered them from PCBWay. They sponsored the boards. They're sponsoring this video. Thank you very much, PCBWay. Once again, the boards came out perfectly. I just hope the design is, because I haven't tested this yet. I'm going to be building this up after I describe the schematic to you, and then we'll see if I've achieved my goal. Everything is pretty simple, actually. What I've got is I've got 12 volts coming in. In this case, I'm using 12 volts DC. I'm going to use a battery, and I'll talk about that in a moment. 12 volts DC comes in through a switch. This switch is labeled medium wave FM for a purpose. This is actually just a simple on-off toggle switch. This capacitor is here just to add a bit of smoothing, not that it's necessary. We have an LED with a current limiting resistor just to tell us that the unit is on. In fact, it tells us that the medium wave or mini whip, I knew I'd fall for that one, MW mini whip rather than medium wave in this case. This LED will tell us that the mini whip is active rather than the FM, and you'll understand that when I show you the faceplate. So this is our V+. That has been switched on through that toggle switch. Let's start here first. We've got a relay. This is that little double pole, double throw TQ2 relay. It's a normal double pole, double throw, as you can see here. There's one section there, there's the other section here, and when you activate it, it switches between that one to that one, and from that one to that one. The two outputs go to the mini whip FM output. That is the mini whip FM output BNC, the one at the front, that's going to be labeled with that, okay? So this goes to your radio. Now what comes in? Well, if this relay is not activated, not energized, then the switches will be precisely in the positions that are shown here. And what I've got is I've got a BNC at the back that comes from my FM antenna, which is one of those, folded dipole antennas that I've got sitting on top of the shelf here. That just comes in there and goes straight through to the antenna. See that? So if I don't switch this unit on at all, this relay's off, my FM antenna is permanently connected to that BNC socket. Okay, what happens if I activate this? Well, these switches flick down, okay? So what's going to be seen there is going to be these two. In other words, these two. And what are these two? Well, these two are actually a signal coming from a secondary or from one winding of a balun. Again, I'll describe that when I show that to you. It's an isolation transformer, effectively. It should be 1-to-1, I think. I think I've got it as 1-to-1. It's about 20 turns on a core. And the secondary is completely galvanically isolated from the primary. The reason for this is that this actually reduces a lot of noise. So this is our antenna from the mini whip, the signal only, going through to the BNC socket output over there. Now, how does the antenna get here? Well, this is our mini whip socket at the back. This connects to the mini whip. And what this does is it brings the mini whip signal through here, through this capacitor, to the one winding of that balun. And that's between that and ground. So our signal's coming in, our radio signal's coming in here. It goes through the capacitor because it's AC, and it energizes that coil in the balun, okay? Which then sends a signal that way. But the mini whip needs DC voltage to run. And the way you do that is you take your supply. There's a bit of filtering over here. I've put a diode here. This is a Schottky diode to prevent reverse polarity if you make a mistake. So this just goes straight through. There is a fuse over here. It's a 100 milliamp fuse. This is one of those little PCB mounted fuses that I bought. And this then sends 12 volt supply to the mini whip. See that? This is a straight DC path all the way from there, through there, through there, through there, through there, through there, to the mini whip. That means the mini whip will get 12 volts. A little bit less, but 12 volts. Why do we have all this here? Well, the reason we have the fuse here is if you happen to short the wires, the coax, anywhere along the line, you'll be shorting out the supply. And you don't want to do that. So you put that the fuse in there in case you happen to do that accidentally. The fuse blows, you don't blow the whole supply, okay? The reason you've got this inductor in here is to prevent RF that's coming from the mini whip from going back into your supply, because you might not want that. So this just cuts the RF onto the supply. These are just additional filtering. That, as I said, is a DC blocking capacitor. So again, no mystery there. Now, I could not resist creating this output here as well. I told you I've got that mini whip FM BNC socket, which is the one that I want to have my leads permanently connected to, but I just couldn't resist having a direct out from the mini whip without this balun. So I've created another output at the front, which is probably never going to get used, but it'll allow me to get the signal directly from the mini whip without it going through a balun. Sometimes that might be different. I'm not sure. I might be able to use this for higher frequencies. The balun might actually not pass those frequencies well. I will experiment and test it. As it is, I'm building it like this. Here's the PC board. So this is facing the back. This is where the mini whip input will come into. This is where the FM antenna input will come into. And this is where the mini whip and FM output will go to. When I switch 12 volts to there, it switches the relay. It activates the relay. And this is that direct out. These are the primary leads of the balun. These are the secondaries. I did this like this because I want to build it in a way that I can replace the balun, experiment with different baluns easily. So these will be socketed on the board. I'll show you that when I build it. Okay, all done. These wires are here so that I can then connect them to the sockets, the BNC sockets. Here we've got the LED. This goes to the switch, and this goes to the supply at the back. Now, what can I say about this? Well, the relay is a TQ2 12 volt relay, double pole, double throw. And I've used those before. I've got quite a few of them lying around. They're finally finding some use. The soldering all went fine. And I think I'm ready to put this into the cabinet, into its case, which will be just a matter of slipping in the bottom there and start soldering all the wires to their respective connective points. Shouldn't be a problem. Let me do that. Now here's that isolation transformer that I did. It's bifilar winding. You take two lengths of wire, you keep the two together, you just keep winding. That gives you a primary and a secondary. I can't remember how many turns I've got on here. This is the, I think this is the 4337 or 3743 toroidal core. I tried various cores. I tried all sorts of stuff. I tried different windings. I think this is the one that gave me the best results. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 turns. So each core, or rather each winding, has got 12 turns. And I've connected it to these pins so that I can just socket it into the board over there, which means I can later on, if I find a better transformer or I find something wrong with this, I can just take it out. Well, folks, here's the final result. Looking very, very good. I put the sides on. We've got our DC input at the back. I'm going to use this 12-volt battery supply made up of 3 18650 cells. So if we place that in there, this thing is now ready to be powered up. This is going to go on the underside behind there. It's got a Velcro pad on here. I just take this off, stick it up there. So it should be easy to remove. And if we switch it on, now what happens here is when we switch it on, the mini whip is brought into action by the relay. When we switch it off, the FM comes through here because the relay is deactivated. This one comes straight from the mini whip without going through that little transformer there. This is where the mini whip gets plugged in from the mini whip antenna, and this is where the FM antenna gets plugged in as well. Now this is ready to go up on the shelf, but there was one mistake. What you're seeing there is the second board that I had to build, and what it was, let's see if I can show you this. This diode was the wrong way around. Now the problem with this was when I did the schematic, I was looking for a Schottky diode symbol, and I found one that was user contributed. You've got to be careful with those. Somebody had created a footprint and a symbol, but they had labeled it wrong. They got the anode and the cathode back to front. So when you do this on the schematic, it looks good. And then when you convert that to an actual PCB, it takes the footprint that somebody's put on there. And if there's a mistake there, it'll show up on the final result. So I had to correct that. This thing just wasn't working because the supply wasn't coming through the diode to the fuse, through that inductor to the mini whip itself. But fortunately, I had more than one board. This is now rubbish, and I actually got to do it a little bit nicer this time. It's looking nice and neat inside. I built the entire insides without the sides on, which was the idea originally. But those boards look really neat down there. That little relay is so sexy. I like it. I'm becoming a bit of a fan. And if I want to change the transformer, the matching transformer there, I can do that. But I'll show you the result because I've got access to the signal from the mini whip going through the transformer and going direct, which is this one here. So I'll be able to show you the result and we can determine what the difference is. I've got my two antennas coming in here. This is the FM, so that goes into the FM socket over there. This is the mini whip itself. That goes into there. Now I'm taking this from the output here, from the generic one, the whip and FM, which means that at the moment the FM antenna is coming through here. If I do that, the mini whip is coming through here. But I'll leave it on mini whip because I want to show you the effects on the reception. What I'm using here is the Eaton 750. It's the equivalent of the Grundig Satellite 750 Pro. This is the one I did a bit of a repair on in a video previously. It's a radio that I do like to use because it's very easy to use. It's a little bit unfair because it's all digital, so it's not as much fun as the tube ones. But what I have at the moment is I've got this connected to, well, I've got it set to shortwave, and I've got the shortwave antenna extended as far as it'll go, okay? And I've got the ability in here to either make it internal or external antenna. At the moment, it's on internal antenna, and I've got something here. It's not bad, but what happens when I put it to that one? See that? The noise is pretty dramatic there. Noise goes away. I'll put that off. This is brilliant. It works fantastically. Let me try and find something else. Let's try the internal. You just cannot hear anything. So much noise. Mini whip.
Stand by, everybody please stand by, please.
Perfectly audible.
My name is Bobby, Bravo, Alpha, Bravo, India, Sierra, Bravo, Alpha, Bravo, India, Sierra. Thank you very much.
See what I mean? Let's try something else. Here's one on 13.8 megahertz. That's a very strong signal, so you can hear it, but that is still clearer. I'm actually trying to find a weak station, and all these are very strong. That's with the mini whip. Can you hear the noise?
Yasaklandı. Şu anda ise Çin'de takı sektöründe rağbet gören.
That's with the mini whip. That's with the internal antenna. You actually see a big difference with weak stations as you go down in frequency. There's a weak station. You just hear it. With the internal antenna, you can't hear anything at all. Now, what I'm going to do is I'm going to put this thing on medium wave and long wave. All right, this is what we've got. I've got the antenna coming out of there, going to the external antenna socket at the back of this thing. This is the rod antenna that rotates. And on this particular radio, if you want to put an external for AM and long wave, you've got to put it at the back there. So I've got it going there, and I'm going to start on medium wave. Now, on medium wave and long wave, this is especially good. It's Canary Islands. Just so you get an idea, if I take this off and I use the rod, bugger all, nothing at all. Completely dead. The minute I put the mini whip in, everything comes back to life. This is from the Canary Islands. Just so you know, this is late afternoon. It's not even the best time for medium wave, but listen to this. Let's go to the local station. This is the only local AM station we have here. This is probably the only one that I can pick up a little bit with that rod. Let me show you. It's sort of... That's what I can pick up without the mini whip. Now let me show you long wave.
الملك محمد السادس في رسالة موجهة إلى رئيس الحكومة relative à la mise en œuvre du programme national.
Quite a few beacons up here. Mostly beacons up at this end. But you get the idea. On long wave, I'm probably the only person in Madeira that picks up long wave, because it's not something they listen to here. And most of the radios locally don't have that anyway, and never had them. So this is where we are. That's where this particular antenna shines. It's mostly on the lower frequencies like long wave, medium wave. But I started off with shortwave just to show you that I don't need to change this when I'm listening to shortwave. This thing works perfectly well for me all the way from long wave, all the way up to the top of the shortwave band. And now it's also perfect for FM as well. And I just do that and I get my FM. This little thing is magic, really magic. I love this mini whip, I really do. Makes a huge difference to what I can receive. And it's going to go back up on the shelf there, under the shelf. It's going to fit perfectly with that lip over there, and then I can just screw from the underside, put a screw in to hold it in place. And that is fantastic. I love it. And what I need to do is just connect this behind it, and I've got a freestanding supply. If after a while, I can bring this down and just recharge it. I've got the indications here, 12.6 volts at 0.5 amps, constant current. I actually thought of making this a battery pack that would come alongside this, sort of as a self-standing unit that would also go on the shelf. It's about the same size. So I could make a smaller element like this, because now I can make these any size I like. What I could do then is actually put a little voltmeter on here so you can check the voltage. Remember, when this thing's fully charged, it's 12.6 volts. And I could actually check the voltage and see if it needs to be charged or not. Maybe put a charging plug at the front here. And then this, it would be the other way around. This output would go at the back into the unit that it's supplying. Because a lot of some of the units I have on the shelf, on that shelf over there, some of them are actually 12 volts. So there's nothing stopping me from making a few of those 12 volts units. And I've got quite a few spare 18650 batteries that are just sitting at the top there. Might be a good use for them. But for now, that's the end of my show and tell of my little folly project. I really love playing with these things. And I hope you've enjoyed that. This is not something that's for everybody. I've got a very specific need here. And that's why I decided to do this, because I can. PCBWay has kindly sponsored me with the boards, so it makes it a lot easier for me to do these little things. And if you've enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now, and most of all, stay safe. And I keep saying that because that came from the COVID era, and lo and behold, here I am with COVID. So it ain't over till it's over. All right, bye for now.